Hello my awesome audience, you're welcome to today's section. We have an exciting opportunity to deploy this e-commerce website to AWS using Terraform. So this hands-on experience will not only enable you to fully learn how to launch a functional online e-commerce store, but also empower you to learn and understand how to leverage Terraform for infrastructure as code deployment. Okay, so by the end of this section, you will be able to gain practical experience in using Terraform to deploy real-world applications as well as websites on AWS, setting the stage for further exploration and mastery of cloud native technologies. So are you ready to embark on this Terraform journey? Let's dive into it and explore the world of infrastructure as code together. But before we go ahead, if you are yet to subscribe, please subscribe to this channel because you have a lot of valuable content to benefit from. Also, click on notification bell. That way you get notified each time I publish a new video. Let's get started. So this is my VS Code and I have actually cloned my GitHub repository that we'll be using. I'm going to be dropping that in the description below. Okay, so first of all, you need to actually fork that. So if you open the URL I'm going to be dropping, then you fork that just to have a copy of that in your GitHub account. Okay, after forking that, then you have to clone that from your computer by just opening your terminal and running git clone plus this plus the URL can help you to download the copy of this configuration files to your computer. And after cloning, just open that from here, from your VS Code. You can actually use any other IDE that you're comfortable with. So I have cloned mine and I'm able to see these files here. Also, to follow along, you need to have Terraform installed, you need to have AWS CLI as well as Git, all right? And you also need to configure, your AWS credentials in order to be able to make API calls. I'm going to be dropping the link to help you configure your AWS credentials in case you're yet to do so. So if I right click and say open in integrated terminal, I'm actually using a git bash. That is the terminal I'm using. So ensure you have ensure that if you run AWS configure list, that you're able to see your credentials which you've configured already. If not, then use the link I'm going to be dropping to learn how to configure that. Okay, now we can get started. Let me close this terminal. So go to providers.tf and I have my provider defined already. A provider is a plugin that is responsible for understanding and interacting with specific set of APIs. So in this case, we are using AWS provider, which will allow Terraform to manage resources on AWS, all right, for us. Now let's see, before I explain this provider, let me show you how you can actually get this template. So come to the browser and type google.com and then type Terraform providers, right? See browse providers. I click on it and it should show us list of providers. Let's click on AWS and by the right hand side you see use provider. Just click on it to expand and you should be able to see this Terraform block and providers block. Just copy it, and that is exactly what I did to get the template. So this is the Terraform block, and this required providers specifies the provider that the configuration requires. In this case, it is AWS. Okay, this source specifies the the source of the provider, which is HashiCorp AWS. Okay, and for this version, let's use version 5.31.0. okay, so this version is very current And for this providers block, it is AWS, and the region is US East 1, which is the default region where I want us to deploy our resources into. And for the profile here, I have Helen here. So if you go to your I am in AWS, you need to add the user you have over there. So from my own username, I got this Helen. So please don't use my name, use yours. And you configure this when you run AWS configure. Like I said, I'm going to be dropping the link in the description below so that you can configure yours. I don't want to use default profile. All right. And okay, let me get rid of this stuff. So this is how to configure your provider. All right, so first of all, we'll be configuring our VPC, okay, VPC and the component, because I don't actually want to use a default VPC here. So if I click on vpc.tf, this is the the configuration file to create a VPC, internet gateway, a public subnet, and a route table, as well as creating association between the public subnet and the public route table. So creating a custom VPC for deployment of your website or application or whatever, right, provides more flexibility, control, and security over your network infrastructure compared to using the default one. So it allows you to define or design your network according to the specific requirements and your organizational needs. So let's get started. Here I have a template for creating a custom VPC. And how did I get this? Come to my browser and type google.com in order to be able to get the resource template for creating a VPC. Type Terraform AWS VPC and press, sorry, I didn't actually spell that right. That is VPC. And this is it here. Click on it and it will lead you to the documentation where you can get the template to create a custom VPC. Okay, so that is how I got my VPC template and other resources. So whatever resource you want to get, just type Terraform AWS and the name of the resource you want to create. This is example usage, and I've actually gotten all the templates. So in order not to waste time, I have all the templates already that we'll be using, and I'm going to explain each of them. So here we have the resource block for VPC. This is the resource type, and this is the resource identifier or the resource name. Now for us to, how do we add a CIDR block? You need to decide on the CIDR block you want for your network. Let's use 10.0.0.0/16. All right, instance tenancy, we leave it as default. Okay, enable DNS host, let's leave it as true. And for the tag, I want to say maybe like custom VPC. Great, and that is for VPC. So in this second block, we have to create an internet gateway, okay, and then attach it to our VPC. An internet gateway is like a bridge between your VPC and the internet, okay. Once you attach it to your VPC, it will enable the instances within the VPC to connect to the internet. All right, so how do we get the VPC ID? That is the first parameter here. All I need to do is to scroll up to my resource block of VPC and copy this resource name and identifier. Come here and paste it. I'll remove this double quote and type .id at the end in order to reference the ID attribute, right? And then I'll remove all these double quote and type dots in between. So that is how to join the resource name and resource type of VPC and add the ID attribute. And then for the tag, let me name this internet gateway, just like this. All right, that is all for internet gateway. Let's scroll down and create a public subnet where we'll launch our EC2 instance. So this public subnet, this is the block, and we have to fill in all these parameters, right? The VPC ID is actually the same VPC ID we used here, so I'll just copy it and paste it here. For the CIDR block, let's use then 10.0.0.0/24. Right, availability zone, it should be in US East 1A. Map public IP on launch is equals to true because we want it to assign a public IP address on launch. All right. And for the tag, I rather leave it this way, public subnet AZ1. All right, let's go down. For the route table here, so we'll be creating a route table to help us to be able to route our resource to the internet. So via route table, we should be able to have our internet gateway associated to this. All right, so the VPC ID is actually the same VPC ID we've been using. So let me copy it from here and paste it. Great. So for this route block here, the CIDR block is this from anywhere. So I will leave it that way. The gateway ID is the internet gateway ID. How do we get it? Let's go to the resource block where we configure internet gateway and copy it like this, right? Then scroll down to paste it. Remember the way we've been doing it, right? At the end, type .id, come to the middle and remove this double quote and type dot. Okay, that is the gateway ID. So with that, the route from this public route table would be internet gateway. For the tag here, public route table is actually okay, so leave it. Now we have to associate that public route table with our public subnet, and this is the resource block to do that. Now we need to get our subnet ID, and for me to get it, I need to scroll up to this subnet block. Sorry, just copy the resource name and identifier, come down and paste it, type .id at the end, come and remove the double quote and type dots in between. Great. Route table ID. So let's go to the block where we created our route table and copy this. So this is how to reference, okay? This is how to actually reference and get the ID of resource that you want to reference in another resource. Okay. All right, so the VPC and the component is complete. So let me scroll and be sure we are not omitting anything. Okay, this looks good. So now let's go into securitygroup.tf. Here we have a configuration, a block to create AWS security group, and this will be for our web server. All right, so here so note that security group is a virtual firewall for instances within a specific network. So it will help you to control inbound and outbound traffic based on defined rules. So I want us to enable HTTP access and SSH access. Okay, SSH access will help us to SSH into our server after deployment, and for the port 80 is basically for it to be accessible over the internet. All right, so the first parameter here is the name. So I've chosen to give web-sg, okay, as the name. And the description here is to enable HTTP access on port 80 as well as SSH access on port 22. The VPC ID, let me go to vpc.tf, is the same VPC ID we've been using. So if I go back, I'll paste it here, and that is it. So for this ingress, this is the outbound, sorry, this is the inbound traffic. All right, from AWS console, you should be able to see the name is inbound traffic. So is the same as ingress. Okay, so to define ingress rule, we'll be given HTTP access on port 80. That is it. The protocol is TCP. The CIDR block is from anywhere, so it can be accessible from anywhere. And the second ingress rule here is SSH access from port 22 to port 22. This is how to define this in Terraform. just like a range, right? Protocol is TCP, CIDR block is from anywhere. So for this egress traffic, this is outbound traffic, okay? This allows all outbound traffic from the resource that will be associated with this security group to any destination IP address. So this means that it should be to any destination IP address, okay? So this is a very permissive rule that allows unrestricted outbound traffic from the associated resource. And for the tag, I can say WebSG. All right, so that is it for this security group for our web server. And now let's move to the ec2.tf. So this first block here is to use a data source to retrieve Amazon Linux AMI. So a data source in Terraform is basically used to fetch information from external sources, and in this case is AMI. And for this first parameter set to true, we want to basically specify that the data source should return the most recent AMI. And for the owners here, this ensures that only AMIs owned by Amazon are considered. So for the filter we have here is to basically specify that the owner alias should be Amazon, all right? And this is basically to specify that the owner alias should be Amazon. And we have another filter here. We want to filter this by this will basically help us to specify that the name of the AMI, should match the pattern. That is the pattern here. So we don't want to just fetch any AMI ID. We want to use filter options to filter what we want to get. All right. This block is to create an EC2 instance. Okay. So first of all, let's define the AMI. So since we are fetching the AMI from this block, we now have to reference it. And how do we reference it? Copy this data, the resource type and resource name, come here and paste it. So remove this double quote at the end. Once you remove it, type .id, okay? Come towards the middle and remove the double quote and type dot. Remove this double quote and type dot as well to join them. So this is how to reference the data block for our AMI, okay? So that EC2 instance can use that AMI to launch our Amazon Linux server for deploying our website. Then the subnet ID, how do we get the subnet ID? Let's go to vpc.tf and go to where the block for creating our public subnet is the one. So just copy this resource type and resource name, go back and paste it. Type .id. Come to the middle and remove this and type dot. Great. The instance type is T2 micro. The key name. So in AWS, I already have a key pair, right? Going to AWS in the EC2 resource. Let me scroll down and show you my key pair. So I have a couple of them and I want to make use of this Windows key. So I'll copy this. So I'm making use of existing key pair in AWS, and I believe you have already. So I'll paste it here and that is fine. This key pair will enable us to have, to be able to log into this server. For the VPC security group, how do we get it? Let's go to security group. For the block, we have to copy this, come back and paste it inside this square bracket. All right, come towards the middle and remove this. Type dot, and you also want to type .id at the end. Okay, so this is how to reference the security group, and it is named VPC security group ID. Great. For the user data, okay, so we want to make use of user data, which will help us to run scripts for deploying this e-commerce website. Don't want to manually launch a server and then log into it and start running script one after the other. So how do we configure that user data? So let me take you to a file here named command.sh. So here we have our script that can help us to to install Apache and then deploy our e-commerce website. Okay, you want to start your script with shebang, and sudo su is to become a root user, yum update to help you to update the package manager. This line is to install the Apache web server. Okay, and then want to create a directory called dir, and we want to switch into that directory, and this is where we'll now use wget to download this e-commerce store. So I'm basically using a free CSS template. Okay, so if you have a file in your GitHub repository that you want to deploy, you can actually add it as a zip file here so that it can fetch it. Okay, but this, I'm using this directly from this website. All right, so after I download that, it will help me to unzip it with this command, and then it will switch to a directory called this, and then this line will help me to move all the files to this Apache to this Apache directory. Okay, so this is the default Apache page. It will help us to move the files here, and then it will switch to that location, to this part, and it will now run systemctl enable httpd, which is Apache. Please note that this httpd is same as Apache. Okay, it's because we are using Amazon Linux. All right, and it will also start the Apache web server for us. So this way our website will be deployed in our server. So let me go back, and so how do we reference this this command.sh here so that it can run those scripts? That is by typing file and you opening this parenthesis, and inside it type or add double quotes and then type the name of the file. So in this case is command.sh. Ensure that it is the same name that you have here. Okay, it should match. Don't if you use a different name, it will not be able to fetch those scripts. Okay, so this is how to reference that, and we are good. For the tag here, I'm using a test instance, or let me change this to web instance. Great, and this actually look okay. I think we are good. So right now let's validate our configuration. Just on any file here, just right click and open an integrated terminal. So I want to switch to bash. I don't want to use a PowerShell terminal. Okay, so here what we have to do first is to run Terraform init. Running Terraform init will help us to download the provider's plugin, initialize the working directory. Okay, so I'll press enter. You can see it is initializing provider plugin. It is installing the HashiCorp AWS. This is the version. So let's give this a moment. It doesn't really take time. Great, and Terraform has been successfully initialized. If you look over here, you see .terraform directory, all right, like a subdirectory added to our default or our working directory. Okay, and here we have the providers binaries. Okay, that has been added. We also have .terraform.log.hcl that has been added here, and this is a log file generated by Terraform after we ran this Terraform init to record the specific versions of the provider dependencies that we are using to create and manage our infrastructure. So please take note. Now, the second command I would like us to run, let me clear this, is Terraform validate. This will help us to validate our configuration, and it should tell us if it is valid or not. Success, the configuration is valid. Now, we can actually go ahead to run Terraform plan just to see, just to preview the changes that we want to make to our infrastructure. So Terraform plan is to give you execution plan, and it has actually displayed all the resource that the desired configuration that we have. So you just have to take a look, and if you're okay with these resources that Terraform will provision for us, then we can go ahead to run Terraform apply. Let me clear this. So I'll run Terraform apply, and then I'm gonna type all right, let me just run Terraform apply, and I'll show you how to approve the deployment of our resources. Now it is also giving you an execution plan you can take a look at, just as the Terraform plan, right? And now it is actually asking you to, to confirm that you actually want to go ahead. I'll type yes. Now let's give it a moment to deploy our resources and deploy our website in EC2 instance. Great, 7 resources added. Now let's validate. Let's go to AWS and verify that all these resources have been provisioned. So here, still in the EC2 resource, let's go to instances and confirm that it was created. Great, so you can see web instance that it is running, though it is still initializing. Now let's go over to VPC. So I'll type VPC here, click on VPC. Let's confirm that the VPC was actually created, as well as the components. So click on your VPCs and click on VPC. So this is the custom VPC that we just launched. Okay, if I go to subnet, you see public subnet AZ1. All right, other ones are the default subnet I have in my default VPC. Now let's go to route table. I should see public route table. All right, and if I click on this, I've selected this route table. If I go to route tab, I should be able to see internet gateway, okay, which we associated. Now if I go to, let me scroll up, if I click on subnet association, I should be able to see the public subnet AZ1. All right, let's go to internet gateway, see the internet gateway that just got deployed. And yeah, if we check the security group, we should see the web server security group. This is WebSG. Great. Now let's confirm if the deployment, let's go to EC2. On this to check it, and I'll scroll down to get the public IP address. That is what I'm interested in. Now we can confirm if the deployment was successful. Awesome, we've successfully deployed our e-commerce website. Right, so this is how to use Terraform to deploy a website on AWS. Please give me a thumbs up if you enjoyed this video. Subscribe and click on notification. That way you get notified each time I publish this video. Also share this video if you find it interesting. Drop a comment with any questions you have. Like I said, I'm going to be dropping the resources link we use in the description below. Thank you so much. And before you go, you want to come here to the terminal and run Terraform destroy. Okay. So if you are just practicing, I encourage you to destroy so that AWS will not greet you with their bills, right? So I'm going to confirm that I want to destroy all these resources by typing yes, and then all these resources will be destroyed. Thank you so much, and I'm going to see you in my next video. Bye.